Okay, hi everyone. I just finished filming what has to be the most boring video I've ever made. But I teach you all how to calibrate your Delta printer, specifically your Anycubic Kossel printer, using Marlin 1.1.4, the latest release of Marlin as of the release on this video. Now, a couple of notes. First thing, if you have an older version of Marlin, you're going to be adjusting your smooth rod distance instead of your delta radius. And well, I should just give you the short version of what I showed in the video. So the first thing you do is you level each of these points. So you're basically leveling the three pillars to each other. So you skip you skip the level in the middle. You don't get a level dead center. You basically move the end effector to this side, or right up against the leg here, and you lower it all the way down. You get a reading, and you level all three to each other. That's the first step. Once you've done that, then you can level it to the middle. You can set your level in firmware. You set the center point as your 0, and then after that, you move it to the edge of the bed. And at the edges of the bed, if it lifts up, you then have to adjust your delta radius. So it's pretty much that easy. That's what we're doing. But I show you a couple of G-code commands to accomplish that. Specifically M211S0, which disables software end stops. And also just a couple of moving commands. I don't know if I have that paper under. Here we go. G0, X -70, Y -41, and G0, X 70, Y -41. So also G0, Y 80. So those are the three movement commands that gets you right up against these legs so that you can zero each of those legs. So yeah, with that information, you really don't need to watch the rest of this video. I'm going to go over all that again if you're confused. And yeah, it's a boring video. I was bored making it, you guys. But it gives you the information if you don't know how to calibrate your delta. And you know, this tedious process is the pits. It's terrible. So we're really looking forward to the next video where I'm going to show all of you guys how to install this BL Touch auto mesh bed leveling. Pretty cool stuff. This will make it a whole lot easier than having to manually calibrate. So definitely my vote is get that. Now this is an expensive sensor. This is a $30 sensor. This is a cheaper sensor. These are $3, so 10 times cheaper. But I don't know if I can get this one to work, and the BL Touch is just so cool. So tune in next time. I don't know when that's going to be though, so it might be 2 weeks to a month. The thing is, I'm having a baby here any day now. And also my startup company just launched yesterday. Go check that out. I'm going to link to it in the description down below. Shameless plug. Go look at my company. And if you're bored of this ramble and you don't want to watch a boring video, right here in the card I'll link to something that's better for you to watch. But anyway, yeah, that's about that. So thanks for watching. Hope you learned something in this. Oh, hey, one more thing. This might be the last video I make about this Delta printer. So if you get this printer, make sure you replace your Baud tube. You got to get this PTFE. I think that's what it's called. PTFE? Yeah, I'm pretty sure. The plastic tube that comes with it has a lot of friction, and you're going to have problems. I had problems. So I kept forgetting to mention that. Alright, well, terrible intro to a terrible video. I apologize, but it gets the information there, so hopefully this helps somebody. Do me the favor and click all the good buttons. Alright, let's get into it. The first thing you need to do on the computer is go to Arduino.cc and get the Arduino Ide environment. It's a programming environment that you'll need to use to run and upload the firmware, the Marlin firmware. So Arduino.cc, and somewhere in there is you'll find the downloader. You should know how to do that. So once you've done that, you can go to do a Google search for Marlin firmware, and you can download that. I would recommend going to Marlin FW. There we go, and you can download the latest build. Now, like I said, I have Marlin 1.1.4 working, and that is the latest as of the making of this video, very new release. And I've gotten it to work fantastically with this Delta printer, specifically the Anycubic Kossel printer. And so if you want a copy of that firmware, you should go to my Patreon page and donate $5 or more, and I'll send you a copy of it. Now, for those of you who want to give me grief because I'm charging for open source software, a couple of you in the last video really took me to task on this. Well, I went and looked it up. It's licensed under the GNU GPL version 3. That's what Marlin firmware license under. So you go look up that license here, and it says that you are free to charge for the software. So I can just charge you for that if I want to, but I'm not in the software business, you guys. I'm not that good of a programmer. I just happen to have a working version of it that works great, and I got help from an actual programmer to make sure that everything was on, working great. So if you go donate $5, I'm going to give you everything I've ever made for this printer. All the STLs. You'll have the same printer that I have. Okay, let's look at this folder. So this, I have it called the Kossel scratch build. That's what yours would just be called Marlin or whatever it's going to be called when I ship it to you. And then you click on Marlin, and you go down here to your marlin.ino, and we'll just double click on that, but I've already got it open, so that's going to look like this once you open it. Now you've got all these sketches is what they're called, these little sort of files, these little text files that are part of the program. They're called sketches in the Arduino environment. And you want to go to the sketch called configuration.h. That's pretty much the one that you'll ever touch. That's the only one you'll ever touch. If you get advanced, you can get into configuration advanced.h. I had to go in here a little bit to mess with fans, the fan pins to get this working. Now, then the first thing you want to do is after you've connected the USB cable between the board on your printer and your computer, you need to go up here to Tools at the top and go down to Port and make sure that you're in the correct port. Now, you also need to then open your serial monitor. Once you do that, your board will restart. If this doesn't work, if you don't see all this actual numbers and letters that make sense, you just see a bunch of gobbledygook, what you need to do is change your baud. Now, it's probably set to 250,000, but it might be set to something else. When you're in configuration.h, you'll scroll down to the Delta settings section, and then there's only really two settings that we're going to mess with. The first one is right here, it's the Delta height, and that's your Z height. That's for zeroing out the bed. We're going to be messing with that a lot. And the other one that we're going to have to change is this delta radius. So, you know what? Let's change it to be 100, because that's what they think it is at the factory. 100. And we will change this to be an even 330, because we need to figure out those values. So before we do any of that, though, what I'm going to do is upload this sketch to the printer. The reason I want to do that is because I don't want it having the original values, the values that work. I want it to have values similar to what you guys are going to have. So I would recommend starting with 330 if you have those end stops near the top. That's probably going to be about right. And then, like I said, the 100 is kind of what this printer is designed to have. So also probably about right. We're going to try to get all three of these set screws. These are the end limit screws. We're going to try to get all those to be pretty much exactly the same height. Now, I have this, it's like this fake credit card that they sent me in the mail from my internet service provider. They're trying to get me to switch. Those crooks. I hate them. But they sent me this little credit card, and we're going to use this because it's a whole lot easier than trying to do this with calipers. So what we're going to do is I'm just going to hold this up to the screw head right here and kind of take a rough estimate. I'm going to make a little snip on this, and I'll show this close to the camera here in just a second. And then I'm going to cut it like that. Okay. Can you guys see what I've done there? I've cut that little notch out of it. Now we're going to nest the head of the screw into that notch. Right here, it looks like I'm a little bit tall, and you know what? Because this is my first one, I'm just going to trim this rather than adjust the screw head. So that's pretty much right on it. So, starting with this one as my guide, I'm going to go to the next one. And that one is high, so I need to thread this one down. Oh, I got the wrong Allen key. Give me a second, I'm going to grab the red Allen key. Okay, so that's it. All three of those are calibrated to be the same height using this little makeshift guide. So one thing before you even do that, you need to make sure that your end stop switches are as exact as, like, they're all placed exactly the same height from something. Okay, so I went from I made sure that everything was all put together as tightly and as perfectly as possible. So I spaced them off the top up here, but you might want to space them off the bottom, put a ruler in there or like a long stick and space them all exactly the same. But just having everything be as close to exact in the beginning, as far as the setup where everything's screwed down to, that's going to help you a lot. It's going to make your life a whole lot easier. So, okay, now that we've got everything and we think just sort of like by eye calibrated perfectly, we're going to go back to the computer and we're going to start doing this digitally. Okay, so here I am looking at my, this is my actual printer, and we can start sending this G-code commands through the text editor window right here. So I'm just going to type G, and everything has to be a capital letter here. So G28 and enter, and what that does is auto homes the printer. So now what you guys can't see off camera is that my printer is actually going to the top, and it just hit the 3 end stops and then dropped a little because that's what it's supposed to do. So it's now auto homed. So now what I can do is type G0. Oh, I gotta have my, so I'm gonna put my cap locks on. G0, and that means that's a movement. G0 and G1 are both movements. G1 moves a little faster than G0, so we'll just change that to a G1. G1 Y80. So this is going to place the end effector at the 80 position. So it's towards the back, and it's almost touching the belt. Okay, so this is your command. It is M211 space S0. Remember, you have to have all capital locks. Press enter, and what you will see is this place where it says Echo Soft End Stops off. So in other words, that's the software end stops. That is the number. If you go back here and look at your firmware, that is your 330. That's dictating that height. So we've just turned the printer end stop at 330 off, so we can travel beyond 330 millimeters. So going over here to the actual printer, we're going to press the middle button, down to prepare. We're going to auto home. And once you've auto homed, it'll then know where it sits and it'll allow you to do some movement. So, move axis, we'll move our Z, and we'll move it by 10 to begin with here, and we'll go down. Don't want to go too fast because we've turned our end stops off, so we have to be very careful here. So now we want to move it by 0.1, and I'm at 99. I love this knob because I've got this little ball end that I put on it, so you can just spin it with your finger like that. It's better than having a depression. It's having a thing. But let's not be ridiculous about this. Let's move this by 1 millimeter. So now, 51, 30, 20, 13. I'm looking pretty close to the bed here, but I'm going to keep on going down. So I'm now at negative 1.1, and I'm now at negative 3.1, and I'm pretty close. Like, I can see a gap in there. This credit card thing still fits under there, but just barely. But you know what? That's good enough for us. So it's negative 3.1, and we're going to leave it there for a minute because, actually, let's lift it. Let's go back here to the computer because I find this easier to do. So let's go G0, Z10. And remember, we're negative 3.1. Oh, here we are. Right there. G0, Z10. Okay, so now we know we're not going to have a collision. Now we're going to type that G0, Y80. And you'll see that the printer is going to move to that far edge right there at the pillar. So what we're going to do here is we're going to find the Z height at this pillar, and we're going to raise and lower the end stop screws here at these two, so that these two pillars all are at the exact same height. And we do not need to do it at the middle, so we're going to always do it at this edge. So at that edge there, it is, so let's go down to G0, Z, negative, what? Let's just go negative 2.5. So we know we're still above the bed. We really don't want to collide with the bed, so I'm definitely still above the bed. Now I'll move over here, and remember my end stops, my software end stops are turned off. So prepare, move axis, move Z, move 0.1, and we'll just start lowering that. So we're at negative, and I think I'm about there. So I'm going to grab my piece of paper here and slide it. Now let's just tear this piece of paper in half, shall we? Okay, so slide that under there. It's definitely not hitting the nozzle, so I will prepare, move axis, move Z, 0.1. There we go, negative 5.3, and it's hitting. It's perfect. Negative 5.3. So I'm going to write that number down just because I don't really want to, negative 5.3. You don't want to zero it out yet because you don't know where the other two towers stand. So, now what we want to do is come back here to the computer. Okay, so back here at the computer we want to go G0, Z10. G0, Z10, Y0. And then we want to put the end effector right up against this one. Okay, so our next command is G0, X, negative 70, Y, negative 41. And you see that moves us to that pillar. So we're basically at the same spot that we were when we were at X, when we were at Y 80. So that's where we want to be. Now, just like before, we want to go G0, Z1. That'll get us close. And then we're going to use our knob here again. So into prepare, move axis, move Z, move by 0.1, and we'll move it down until it touches the paper. Okay, I'm touching the paper at 4.7. So I want to be down 5.3, so I'm high. I need to go down farther. So I'm high by 0.6, which isn't a lot. If we look on our calipers, we can measure 0.6 of a millimeter. That's really quite close. So that's going to be what, 6 sheets of paper. So that's about a thread's width on the screw here. So what I'm going to do is give this screw a full turn. And that's a full turn, and hopefully that'll get us pretty close. So now we got to G28. And once again, G0, X, negative 70, Y, negative 41. And then G0, Z, let's just go down to Z1. And then back to here, prepare, move axis, move Z, move by 0.1 millimeters, and start lowering. That is touching at 5.3. 5.4, it is, yeah, that is perfect. So I lucked out. I got exactly a thread width was right. So that was too easy, you guys. You'll probably have to do it twice. But let's go over here and do this other pillar. So to do that one, we again want to go G0, Z10. We don't want to have any collisions. And then we want to go G0, X70, Y negative 41. And that will get us to that other pillar. Okay, so now we're there, and we're going to do the same thing. Prepare, move axis, move the Z by 0.1, and start going on down. So where's my sheet of paper? It's right here. So at negative 3.3 versus 5.3, so I need to go down 2 millimeters. Now looking on our calipers, 2 millimeters is quite a long ways. So something's off on my printer to be that far off because I had measured those nuts, but hey, that's the way things go. And let's just get that adjusted now. So judging by the fact that I have to go down 2 millimeters, I might want to just, it's a long way. Let's just look at this like that. Unfortunately, I think I've just about bottomed out on this hole. Hopefully I've got a few more threads left. It's getting kind of hard for me to turn this one. But we'll see. It is plastic. So let's try that now. G28. Now while it's doing that, you can send the next command, and that's exactly what I'm going to do here. So we're going to go G0, X70, Y negative 41, Z0, all in one command. Back to the knob, prepare, move axis, move Z, move 0.1, negative 3, 4.6, getting there. That is almost right. It's just a hair bit too high. So I went a little bit too far, so I will lift that back up just a hair. Okay, so what we've now accomplished is, all three of these pillars are level. Now what we don't know is how much scooping the end effector is making because of the radius, the distance of these uprights relative to each other. So we can right now G28 and then actually auto home this in the middle. Okay, so the middle and the outsides might not correspond because, like I said, we might have scooping. So let's just do an auto home. And then what we're going to do is we're going to go G0Z negative, it's going to be negative something, negative 1. 2, prepare, move axis, move your Z, move in the negative 1, and we're going to go down until the paper touches. And my paper's touching at negative 4.7. So there is some scooping going on. We are definitely higher up at the edges than we are in the middle. So just let's take that negative 4.7 number, and what we're going to do is go over here into our firmware, and we're going to add 334.7 to the 330. So we can say that our printer is 334.7 up. Now, something else that we know is that it's higher on the edges than it is in the middle. So if it's lifting towards the edges, that means that this radius is too large. So let's just decrease that to 99. And we'll try again. So we're going to keep lowering this delta radius until that scooping goes away. So we'll try 99, and we will upload that sketch. Okay, so we just did that. So now what we can do is Tools, Serial Monitor. If we close this, well, we don't need to close it down. So let's just go G28, and then G0, Z0. So the neat thing about changing that delta radius is that it will not affect your 0 position in the center of the board. So that'll stay constant. So this should still be, yep, it's just barely touching. I have just a little tiny bit of friction there. In fact, let me just to double check myself, I'm going to M211 S0 that, and then we're going to go over here, prepare, move axis, move Z by -0.1, and yeah, we're pretty firmly touching now. So that is true. So that so we're back to here. So okay, so we know that we're touching right here in the middle. Now we were lifted way high on the edges before. So what we want to do is go G0, Z1, and again, we're just lifting it a little bit off the bed so that we're not going to drag along the bed because we don't want to damage anything by colliding with the bed. So we lifted it just a little bit, and now I'm going to go G0, Y80, and that's going to put us back there in the easy to look at position. And I'm seeing a humongous gap. So what that means is the radius needs to still go even smaller. So we can try 98, and we will upload that. I was just editing this footage, and there was about 35 minutes of super boring repetitiveness where I was just raising and lowering the end effector using the G28 home all command and then the G0 Y80 Z0. Now, in between each of those cycles, I was changing the firmware value for delta radius and just lowering it very slowly until I got to where the G0 Y80 Z0 touched with the paper. And then I just double checked it in the middle, and well, that's the footage that you're going to see right here. Let's go to G0 Y80, or I'm sorry, X0 Y80. And a little tight there as well. Still is tight. Interesting thing is, as I move it, G0 Y0, enter, it loosens, and then it catches again right there in the middle. So it's kind of doing a micro lift in between those points. Now, what that could be rod length. It's very slight though. We're within 0.1, and I really have no accurate way of judging rod length. So perhaps I could start to mess with the rod length now and try to get it perfect. But you know what? This is good enough for a manual level job. It really is. It's really not worth your time. You're going to get it perfect, and then you're going to, bump it, and it's going to be off. So there's a reason why you want to get the auto level, and that is because it'll level itself every single time that it starts to print, and you don't have to go through all this tedious work. I'm just going to call this the end of the video, and congratulations, you made it through the most boring thing that I will ever post on YouTube. I hope it was helpful. See you next time.